Welcome to JD's Prep. In this problem, we are given the system of equations x minus y equals 3 and 2x minus 3y equals negative 1. We want to know which of the four systems of equations given in numbers 1 through 4 will yield the same solution as the given system. One thing to notice right away is that if we are looking at the second equation in our system of equations, the 2x minus 3y equals negative 1, all four of the systems in numbers 1 through 4 have exactly the same second equation, 2x minus 3y equals negative 1. So there's no question that that equation, being the same as the one that we're given, is going to lend itself to yielding the same solutions. So all of our focus in this problem is going to be on that first equation, the x minus y equals 3. If I can find a first equation in one of these four that has the same solutions as the x minus y equals 3, then we're going to have a system of equations that yields the same solutions as our original. And in order for the equation to yield the same solutions, I can at best multiply both sides of the equation by the same number. And so, what I want to do is I want to go through each of the four and look at what number I multiplied the right side by, and see if I can get the left side by multiplying by the same number. So for instance, if I'm looking at number 1 here, in order to get to the negative 6, I have 3 times negative 2. So, if my left side here, if this left side is negative 2 times x minus y, then I have an equivalent system of equations. But if I do negative 2 times the x minus y from the original equation, I'm going to have negative 2x plus 2y. And negative 2x plus 2y is not the same thing as the negative 2x minus 2y. So this first system is going to yield us different solutions. If I go down to number 2 here, I have 3 times 1, because the right side of the equation did not change at all. But if I don't change the right side of the equation, I cannot change the left side of the equation either. But here, looking at the left side, the negative 2x plus 2y, this is negative 2 times the x minus y from the original equation. And if I multiply the right side of the equation by one number and the left side of the equation by a second number, then I'm going to get a completely different equation. So number 2 is out as well. Moving over to number 3, in order to get the right side of the equation, we multiply 3 times 2. And so if we multiplied the left side, the x minus y, times 2, and get the left side that we have in this equation, then we will have the same solutions. If I try 2 times x minus y, I end up with 2x minus 2y, which is exactly the same as what we have here on the left. So the equation 2x minus 2y equals 6 has exactly the same solutions as the equation x minus y equals 3. And since the second equation in the system did not change at all, that means the system in number 3 has exactly the same solutions as our original system, x minus y equals 3 and 2x minus 3y equals negative 1. If we look down at number 4, just to cover all three of these here, if we multiply the right side, the 3 times 3, we get to the 9 in this equation. But for the left side, I would need 3 times x minus y, which would be 3x minus 3y. And that is not the same as the 3x plus 3y that we're given here in number 4. So the only one of those four systems of equations that will yield the same solution as the one we started with is the one in number 3, because we multiplied that first equation on both sides by the exact same number.